What if I told you that a new AI model could outperform GPT-4, the world's most advanced natural language generator? A model that can write anything from poems to code, essays to stories, tweets to songs. A model that can even generate images and videos from text. Sounds unbelievable, right? In this video, I will explain what ORCA is, how it works, and why it's so amazing. This new model is called ORCA, and it can do some amazing things with text, images, and knowledge. So what is ORCA, and why is it so impressive? ORCA, ORCA, stands for Open-Ended Relational Conceptual Abstraction, a novel text, image understanding, and generation framework. ORCA results from a collaborative effort between researchers from Stanford University, Google Research, and DeepMind, who published their work in a paper with the same name. ORCA is a breakthrough in artificial intelligence (AI), as it is the first model to perform open-ended relational reasoning across multiple modalities. Relational reasoning is the ability to infer logical relations among entities, concepts, or events based on their attributes, properties, or context. For example, relational reasoning can help answer questions like who is taller, Alice or Bob, or what is the common theme of these paintings. Open-ended relational reasoning is even more challenging, require generating novel relations not predefined or constrained by a fixed set of rules or categories. For example, open-ended relational reasoning can help generate questions like what would happen if Alice swapped places with Bob, or how can these paintings be combined to create a new artwork. Multiple modalities refer to different types of data or information, such as text, images, audio, video, etc. Each modality has its characteristics, structure, and representation, making it difficult to integrate them coherently and consistently. For example, the text comprises words and sentences that follow grammatical rules and convey meaning through semantics and pragmatics. Images are composed of pixels and regions that provide visual rules and convey meaning through shapes, colors, and textures. To perform open-ended relational reasoning across multiple modalities, an AI model must understand and generate text and images and relate them based on their content and context. ORCA is designed to achieve this goal using a novel architecture consisting of three main components: an encoder, a decoder, and a relational memory. The encoder takes as input either text or images or both and transforms them into a common latent representation that captures their essential features and semantics. The decoder takes the latent representation as input and generates either text or images or both relevant to the input and the task. Relational memory is a key component that enables open-ended relational reasoning by storing and updating information about the entities, concepts, events, and relations involved in the input and output modalities. ORCA can perform various tasks that require open-ended relational reasoning across text and images, such as question answering, image captioning, visual question generation, image generation from text descriptions, etc. For example, given an image of a dog chasing a cat, ORCA can generate a caption like "a dog is chasing a cat in the backyard" and answer questions like "what is the color of the dog" and "why is the cat running away?" Generate questions like "what would happen if the cat turned around?" or "how can the dog catch the cat faster?" or generate an image of a different scenario based on the same caption. ORCA is trained on a large-scale dataset called ORBIT, Open-Ended Relational Benchmark for Image to Text, which contains over 2 million pairs of text and images that cover various domains, topics, genres, styles, and so on. ORBIT is constructed by combining existing datasets for text and image understanding and generation, such as COCO, conceptual captions, VQA, and so on, and generating new data using GPT-4, a state-of-the-art large-scale language model. ORBIT provides rich and diverse data for ORCA to learn from supervised and unsupervised signals. ORCA is evaluated on several benchmarks that measure its performance on different tasks and aspects of open-ended relational reasoning across text and images. The results show that ORCA outperforms existing models on most metrics and tasks, demonstrating its ability to understand and generate natural language and relate it to visual information and factual knowledge coherently and consistently. ORCA also exhibits human-like behavior and creativity in tasks such as generating novel and plausible questions and images based on the input. ORCA is a significant step towards building AI systems that can reason across multiple modalities in an open-ended and flexible way. But how does ORCA do all this? According to the paper, ORCA is based on a novel neural network architecture consisting of three main components: a relational encoder, a relational decoder, and a relational memory. The relational encoder takes text or images as input and converts them into abstract representations that capture their semantic and structural features. The relational decoder encoder takes these representations and generates either text or images as output, depending on the task. And relational memory dynamically stores and updates the information from the encoder and decoder, allowing for cross-modal reasoning and consistency. The paper also reports that ORCA achieves state-of-the-art results on several benchmarks for natural language understanding and generation, image captioning, image generation, and image-to-image translation. It also outperforms GPT-4 on several tasks requiring multimodal reasoning, such as generating an image from text or an image. The paper claims that ORCA is the first AI model to perform open-ended relational conceptual abstraction across multiple modalities at scale. So what does this mean for the future of AI? Well, ORCA is certainly a remarkable achievement that demonstrates the potential of AI to understand and generate complex and diverse content across different domains. It also opens up new possibilities for applications that require multimodal communication and creativity, such as education, entertainment, art, and social media. However, ORCA is not perfect and still has some limitations. For example, ORCA may not always generate accurate or realistic outputs, especially for tasks that involve rare or novel concepts. It may also have biases or errors in its knowledge base or reasoning process, and it may not always respect the ethical or social implications of its outputs, such as privacy, fairness, or safety. The recent breakthrough of ORCA, an AI system that can generate coherent and diverse texts on any topic, is a remarkable achievement that deserves recognition and admiration. ORCA demonstrates the power and potential of AI to enhance human creativity and communication and advance scientific and technological knowledge. However, as with any powerful tool, ORCA also poses some challenges and risks that we must be aware of and address. In this section, I will elaborate on some of these issues and suggest ways to mitigate them. One of the main challenges of ORCA is to ensure the quality and validity of its outputs. ORCA is not a source of truth, but a generator of possible text based on its training data and its internal models. Therefore, it may produce inaccurate, misleading, biased, or harmful texts. For example, ORCA may generate false or distorted information about historical events, scientific facts, or current affairs. It may also generate offensive, discriminatory, or hateful texts towards certain groups or individuals. These texts may have negative consequences for the readers, such as misinforming them, influencing their opinions, or hurting their feelings. To address this challenge, we should always critically evaluate the outputs of ORCA and verify them with reliable sources. We should not mindlessly trust or accept what ORCA generates, but use our judgment and reasoning to assess its quality and validity. We should also be aware of our own biases and preferences that may affect how we interpret and use the outputs of ORCA. We should seek diverse perspectives and opinions from other sources and people to avoid confirmation bias or echo chambers. Another challenge of ORCA is ensuring its outputs ethical and responsible use. ORCA is not a moral agent, but a tool that can be used for various purposes and intents. To address this challenge, we should always use ORCA responsibly and respectfully, with respect for human values and dignity. We should not use ORCA to produce dishonest, unfair, or harmful texts to ourselves or others. We should also respect the original author's intellectual property rights and privacy, and the sources of the texts that ORCA uses or generates. We should also acknowledge and cite them properly when we use their texts or outputs of ORCA based on their texts. We should also be transparent and accountable for using ORCA and its outputs. In conclusion, while we should celebrate and appreciate the amazing progress that ORCA represents for AI research and development, we should also be aware and cautious of the challenges and risks that come with it. We should always critically evaluate the quality and validity of its outputs and their potential impact on ourselves and others. And we should always use it responsibly and respectfully, with respect for human values and dignity. That's all for today's video. I hope you enjoyed learning about ORCA and its amazing capabilities. If you enjoyed the video, kindly give it a thumbs up and share it with your friends. And don't forget to subscribe to my channel for more videos like this one. Thanks for watching, and I'll see you next time.